Hello. Yes, we welcome you back to PSSB, Physical Sciences Silver Bullet. And it's me, Richard, once again. We are having a look at this question. It says, state Newton's second law of motion. As we are starting with the question, I would urge you to subscribe. It is to your advantage. This channel, we believe, is going to be one of the most important channel in this field of physical sciences. Please give it a chance. You'll not regret. Okay, let us look at the question, the second law of motion. What does it say? Okay, it states that when a net force acts on the body or an object, the object will accelerate in the direction of net force. The acceleration will be directly proportional to the net force and inversely proportional to the mass of the object. So that's it. Let us put it down. So after that, yes, then comes the next question. It says a block of mass 80 kilograms resting on the rough surface is suddenly pushed by force F. The block gains a constant acceleration of 2.5 meters per second squared. The coefficient of kinetic friction between the surface and the block is 0.5. So this is the diagram we are having here. And the question comes, it says, draw a free body diagram showing all forces parallel to the displacement. Okay, how do we go about that? Okay, they said free body, so we are having our dot. Thank you. And we indicate all the forces here. They are saying parallel, so which means that only those forces which are within the direction of displacement are going to be considered. What forces do we know? We know our applied force here. And what else do we know? Remember, here we are talking about coefficient of kinetic friction. That implies that there is friction force. So friction force comes here because it always opposes motion. So we have it here as our Fk. And those are the only two forces we have in play which are in the direction of displacement. Okay, let's look at the next question. So that is that. And then comes the next question. It says, calculate the magnitude of applied force. How do we go about this? From the diagram, we have to remember that because the body is being pulled towards that direction, that's why it's going. So we are having F net equals to F cos 0 plus Fk cos 180 degrees. That's what we have there from the free body diagram. What is next? Next is we can simplify this one to give us F minus Fk Q. But we know F net is equal to MA. So we can find it. We say F net is equal to ma. And what is the mass? The mass is 80, and acceleration was given here as 2.5. What you get out of that is going to be our net force. Let's get it. So there we are. We have the net force. So when you substitute there, what are you going to get? We are going to get 200 is equal to F minus Fk. But we know Fk is given by mu k Fn. Okay, so what do we have here? Fk is equal to mu k, normal force is mg, so you can substitute for that. Our mu is 0.15 and our mass is 80, and comes our g. What do we get out of this one? Let's see what we get. So there we are. We have our Fk. So we can now substitute it here, and we say 200 is equal to our applied force minus 117.6. When you arrange this one to find our unknown, we are going to get 200 plus 117.6, and you get your answer. Let us get it. So there we are. Our applied force is 317.60 newtons. And with that, would like to thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet. And it's me, Richard, once again. See you next time. Don't forget to subscribe. Bye-bye.